Hello everybody, my name is Josh and I was a computer science examiner for multiple exam boards, head of computer science in UK based schools, and now I run a tutoring business. Today's lesson was requested by people in the comments. If there are any other topics that you want me to cover, please do comment. I'm happy to help and happy to create lessons based on what you guys want. So message in the comments if there's any other topics that you need covering before the exams. The big thing that I would recommend on this one, make flashcards on all of the different questions. Generally with databases, it's a lot of knowledge-based questions about what certain keywords mean. This is something that you can definitely do to drive improvement in your exams. Flashcards, and just go over them until you can remember the definitions word for word, because I've used my examiner expertise to be like, these are the definitions that you need to remember for these. So without further ado, let's get going. So what is a database to start off with? An organized collection of data into fields and records. A flat file database is a database that only has one table. An entity is a category of object, person, event, or thing, or of interest, which the data needs to be recorded. You would normally see a well-made database will have a table per entity. Now, in badly made databases, you actually have the entities all mixed up together, which we're going to talk about some of the problems with a flat file database where all of the entities are mixed up with each other. A relational database is where you've got more than one table connected through relationships. You would also use foreign keys and primary keys to connect those. A primary key is a unique identifier of a record in a database. Foreign key, a primary key from another table used to create a relationship between the two tables. And a secondary key. So a secondary key is very, very similar to a primary key. It uniquely identifies a record but isn't the primary key, and can be used when narrowing down a search or indexing of the data. Entity descriptions, sometimes they ask you to do an entity description. Now the table name, the table name is going to be displayed on the left hand side, so like customer, product, and subscription. The entity descriptors, or the field names, so the column names, they would be displayed here. So you've got customer ID, title, first name, surname, and email. And then the other thing that you've got is you need to have the primary keys underlined. So the primary keys are what uniquely identify each of the records in there. Now, when we start talking about normalization, composite primary keys are where we join two attributes together to create a unique identifier for this. So for example, we could join together order number and order line to create what's called a composite primary key. This will become more important when we start talking about normalization and how we go from an unnormalized database into third normal form. But generally, that's what a composite primary key is where we take two identifiers and join them together to create a unique identifier. One of the questions that you could get is where it will get you to do what's called an ERD diagram, which is an entity relationship diagram. And there's three different relationships that you can get. You can get a one-to-one, a one-to-many, and a many-to-many. Generally, you will always be trying to go for either a one-to-many, or in a perfect circumstance, or you'll be going for a one-to-one. A many-to-many is generally seen as is not good, and we will be talking about why that is in a second. But things that you can do when you're trying to draw your entity relationship diagrams, a couple of little tips, is if they're giving you some databases and they've given you the different tables on there, a one-to-one would be a situation where, so the example I've given here is a car and the employees. So the employee, one employee has one car, so that they have owned, it's a one-to-one, one employee to one car. A one-to-many might be a mother to children. So the mother has multiple children, but with the children being paired up with their mother, the mother may appear multiple times. So that's where you would get a one-to-many relationship. A many-to-many is actors and films. And normally this is displayed by a flat file database, which we'll look at in a second why a flat file database is not preferable. Referential integrity is another keyword. There are a lot of keywords in the database unit. Referential integrity means that no foreign key in one table can reference a non-existent record in a related table. That's a little bit of a confusing definition, but essentially what that means is referential integrity. If I needed to put in, let's say that I needed to put in the BMW, and we had a car database, and what happened is I accidentally missed out one of the letters in BMW. This has created an inconsistency, which then means that I no longer have referential integrity. Because I don't have referential integrity, that can cause issues when I'm trying to search. Because if I say that I need to display all cars that are BMWs, I put in my reports that I need to output all of the data for this, but it's not going to pick up on the values that I've spelt BMW wrong on there. So the inconsistencies can cause problems with searching, and that's why that we need to make sure that all of the data, if we are referring to something, that they are spelt the same all the way across the database. Little example here of some of the key features on there. So customer ID, sub ID, and product ID, these are unique identifiers. These are the primary keys here. You can see that the link has been created from customer ID and customer ID here. That is where we've used the primary key, and now it has become a foreign key in the subscription table. Product ID is also going to have the foreign key here. So I just wanted to show you an example of primary keys, where you've got the foreign keys, you've got, so creating the links between the tables there. You've also got a couple of other things in here. So we've got the field. So the fields is like customer ID, title, first name. So these are the columns, and then the records, they are the rows in there. And all of that together is, we've got the table, the customer table, the subscription table, and the product table. Now with this, if I was trying to represent this in an entity relationship diagram, this is actually quite important. So a lot of people don't understand where they would need to put what's called the crow's foot. So the crow's foot is when you're drawing the entity relationship, it goes on the table. Okay. Now, a little tip to knowing how to do this is the crow's foot goes on the side where there is a foreign key. So can you see on customer ID and product ID, they are foreign keys. So that is the reason why we have put the crow's foot on there. So if you have a question in your exam and it's asking you to draw an ERD diagram, you're looking at the table, and if it has a foreign key in one of the other tables, that is where you're going to draw the crow's foot onto. In a many-to-many relationship, this would be an example here where you've got multiple entities together. We've got products, which that should be in its own table. We've got customers. It's all jumbled up, and this is generally seen as quite a bad style of database because we get repetitions of data and lots of things which aren't necessarily too good. So with all of these different questions here, one of the big things that I always see is that the answer is actually the same for all of these. So disadvantages of many-to-many relationships, disadvantages of an unnormalized database, which we're going to talk about normalization in a second, and the disadvantages of flat file databases. They all have the same disadvantages, so that this can save you a bit of time by trying to remember how to actually answer these questions. So repetition of data happens in all of these, that's a big disadvantage of these. When you have repetition of data, the follow-on point to that is that it causes data integrity issues. So when I was talking about the referential integrity, because you've got repetitions of data, that then means it's more likely that you're going to make a mistake when you're trying to enter that data into the computer, which then that means that when you're trying to search and you're trying to find things in the database, you're less likely to, because of those data integrity issues. Now, we mentioned normalization. Now, normalization is essentially where we're trying to make the database more and more better designed. And we go from what's called unnormalized to first normal form, second normal form, and third normal form. The question that I've seen on this one is where they'll give you a database and they will say to you that this is unnormalized. What are the steps that you have to go through to get from unnormalized to first normal form, second normal form, or third normal form? So flashcard on each of these, this is what you need to do. First normal form is it shouldn't have any repeating attributes. So I'll show you what that looks like in a second. All attributes need to be atomic. You do not want to have full name. You want to have you want to have first name and surname. So you need to make sure that the data is all split up. So in here, what we've got here is we've got repetitions of data in there. So we've got Monday. That shouldn't, so this is an unnormalized database. This is not in first normal form. So that is a situation there which we do not want to have. So what we would need to do is we would need to start creating a link table in there so that we could start removing some of these repetitions of data. So as you can see here, we've split the entities up, and this then allows us to not get those repetitions of data. So to essentially take it from unnormalized here into normalized, and you'll be explaining this in your in the question, is I will remove repetitions of data, and I will also make sure all of the data is atomic. One of the ways that I would do this is I would create a link table, so split them up into so that there's lots of different tables, and also then I would create a link table where we've got the foreign keys there. Now, second normal form is where we remove what's called no partial dependencies, which is just where some of the data is dependent upon primary keys which aren't relevant to it. And the main way that we shift it into second normal form is all you need to say is with the link table, we use the foreign key to create a unique composite primary key. So we join those two together to create a composite primary key. Generally, because it's not going to be a massive database that's going to be in your exam question, what I would say that you need to do is to get it to go into third normal form is that you can actually probably stop there, because if you've only got to split it into 3 entities and there's only 3 entities there, and you've got a link table and you've created a composite primary key, that would also actually take it into third normal form. In a certain situation, if they did ask you like what does third normal form mean, you say all attributes are dependent on the key, the whole key, and nothing but the key. And what that means is, let's say that you still split it up, and then there was one table, so that you've got the link table, you've created the composite primary key, but one of the tables actually had the instructors on there. You just need to make sure every entity has its own table. If every entity is separate, then they cannot be dependent on the primary key of something that it shouldn't be. So that there is no, what's called is it's dependent on the key, the whole key, and nothing but the key. So it's just those attributes are dependent upon its own primary key and nothing else. That's what that means. But the general thing I want you to go with is to go from unnormalized going into. So what you're going to do is you're going to create a link table, remove repeating data attributes, make sure that everything's atomic, create that link table. With the link table, to get it to go from first normal form into second normal form, is that you then create the composite primary key. And by that, if you've gone through and explained that process, generally it should have gone into third normal form at that point. If you notice though that there is another table that you could create because you've got some instructors or whatever, that would then be how you take it from second normal form into third normal form if it isn't already there. Okay, so now we're going to move on to SQL. So SQL, the format of SQL is select from where order by. Now select is where we get the fields to be displayed, so from the database. From is the table name, where is the almost like the if statement, and then order by if you wanted to go in ascending or descending order. So this is showing you a quick example here. This table here, this is for names and breeds of female dogs. So I select name, breed, so you separate that with a comma, from dogs, so you put the table name, where gender is equal to female, and we make sure that we put that speech marks around that. Now you could put a double equal to in if statements. In SQL, just remember that you actually only put one equal sign. All of the other things are relevant though, so like greater than, equal to, less than, not equal to. That all works exactly the same, but just I thought I'd highlight that it's only one equal sign on the where statement of SQL. Now, the little star here is wildcard, which that is a shortcut for selecting everything. And then you've got from dogs where age is greater than or equal to 4. So that's that. Order by. You've got, if you need it to go in ascending order, so select star from members where num is greater than 10, order by surname. You don't need to put anything for it to go in ascending order. It will just automatically do it. But if you want it to go backwards in descending order, you need to put DESC at the end of it. So this is how you would get data from multiple tables, and you're going to use the join keyword on this one. So the join keyword, what it allows you to do is take data from multiple tables and then display it. So a couple of things which you won't be familiar with. You have to use what's called the dot notation. The dot notation is essentially where we've got like table player dot surname. So we put the table to start with, and then we have to tell it the field name that we're going to that we want. So surname, first name, team name, and table.team. Then what we do is we select both tables in this case, and then this is the join keyword. So you're going to say join table player onto table team dot team ID is equal to table player dot team ID. And it's really, really important here that you join it based on the primary key and the foreign key. So it's the foreign key here. That's how we're creating the relationship between the two tables. So that's the one that you're going to go for on that one. And that's where you put the after the on, and then you just simply put the information in that you want it to go for. So table team dot team name equals Binham. Now, altering a table structure. So one of the things that you need to be able to do is to add a column if you want to. So alter table is the keyword on that one. Table product, add quantity and stock integer is how we would add in a new column there. Deleting or altering the table structure. So to delete a column, we go alter table dot table product, drop quantity and stock. So that's going to delete a column there. To alter the table and say that we need to modify the data type on there, we're changing it into a varchar. That's going to accept essentially up to 30 values. You can put it in there like that, and you just use the modify column on there. Insert data. It's quite important on this one. So insert into, and then you put the table, put the field names, and then you just put the values. Very important that the values that you want to add in match up to the field name. So if you put A345 and you didn't put it in the correct data type as well, that's another thing. So if you forgot the speech marks and you put it over there, it wouldn't work. So you need to make sure it's in the correct order on those ones. Updating. What we do is you use update, set description, and whatever the things that you want to change. And then you just have to identify it normally by the primary key. So that's going to be there. Deleting a record, delete from product where product ID. So using the primary key to help you do that. Now, this is just going to be relevant for the OCR specification. So the ACID principle is atomicity, consistency, isolation, and durability. So it's this idea of that we've got certain properties that are going to ensure the integrity of the database is maintained under all circumstances. And what you need to know for the exam is like what each the A, the C, I, and D all mean. So if we just go through and do those, you can just make a flashcard on each of those, remember the definitions, and then you'll be able to get some marks on those ones. So atomicity, it has to. So if we've got a transaction or we're trying to put something into a database, it has to be processed in its entirety or not at all. So let's say it crashes, you can't process part of the transaction. Consistency, that no transaction can violate any of the defined validation rules. And this is going to help us with referential integrity. So again, just making sure that your database is consistent with all of the data that we're inputting. Isolation ensures that concurrent execution of transaction leads to the same result as if transactions were processed one after each other. So it's just going through and making sure that everything is processed and we're going to get the same result in that regard. And then also durability, so ensures that once a transaction has been committed, it will remain so even in the event of a power cut. As each part of a transaction is completed, it is held in a buffer or on a disk until all of the elements of the transaction are completed. Only then, when will the changes of the database tables be made. So once everything's finished, then it's going to process the actual changes to the database. Now, that's good. That's all we've got for today, people. So I really hope that everything goes well. I'll try my best to get the OOP lesson out for you tomorrow as well. So best of luck. Hope everything goes well, and all the best.